Ladies and gentlemen, welcome to my talk. The title of my talk will be Surface Structuration and Functionalization by Laser. My name is John Lopez. I am a senior research engineer in the French National Center for Scientific Research in France, and I talk today as the president of CLP. CLP is Club Laser et Procédés. It's a private non-profit French association of industrial laser users. Our mission is to promote laser technology and laser material processing in industry. This is our members. Okay, let's come back to the talk today. The outline will be the following. First, I will speak about surface functionalization, and I will explain why laser technology is relevant for such application. I will present different techniques for laser-based structuration for surface functionalization. Then I will conclude my talk. Okay, what is surface functionalization? It is to bring added value to the surface, either by adding a new functionality or by improving existing property. We can replace a process by a green alternative process, and very often it consists in mimic some properties that already exist in nature. So what could be the function that we can bring to the surface? It could be aesthetic, it could be optical. We can work on absorption, on reflectivity. We can change or improve the wetting property in order to switch the surface into super hydrophobic or super hydrophilic, for instance. We can introduce anti-icing property, antibacterial. We can change the resistance in tribology or the flowing resistance. We can improve the shear resistance or change the corrosion resistance, the fatigue resistance, and last but not least, we can remove a cover layer for cleaning or for surface preparation before welding or before gluing, for instance. So today, laser is an industrial tool which could be useful to see, to measure, to illuminate a target, or for information transportation, or for material processing, and this is the point today. Laser deliver intense laser beam with a color, the wavelengths, and it could be a continuous or pulse beam. These tools are reliable, flexible, agile, very easy to automatize, and compatible with process monitoring and control. Laser technology can bring new opportunities in terms of design, manufacturing, and control. It is possible to customize laser material interaction in order to achieve different processes such as cutting, welding, or drilling. Today, I will present different techniques for laser-based structuration for surface functionalization. I will speak about engraving, coating removal, structuring by self-organization, structuring by optical interference, and then I will present polishing and reshaping induced by by surface melting. The first technique is engraving. The point here is to ablate the surface, not to go deeper in the material, but to change aesthetic, to introduce some aesthetic on the surface. This is, for instance, for watch industry, some part for watch industry, for decorative application. This is Côte de Genève or perlage. Can be achieved by nanosecond laser, but as well with a pico or femtosecond laser, in order to improve the quality of the process and to reduce the heat affected zone. If you want to go deeper into the material, you can ablate layer by layer in order to achieve some bas relief on the target, and like that, for instance, so you can engrave directly the part, or you can ablate on the tool. For instance, this is an embossing tool engraved by laser. This is EDM electrode, and this is 3D mold for injection molding. In general, the average power required for such application is between 50 to 100 watts. If you want to go faster than 10 cubic millimeter per minute, it is necessary to improve the average power, but in this case, there is a risk to introduce some uncontrolled melting and not to engrave anymore. Another technique will be to use selective ablation. So I mean you have a cover layer and you want to remove this cover layer on the substrate without damaging the substrate. There are two processes. The first one is to use thermal ablation, and the second one is to use the shock induced by the ablation itself. So there is acoustic wave, a shock wave that propagates from the surface to the bulk of into the material, and because there is a discontinuity between the cover layer and the substrate, you will remove by the laser pulse. For which application? The first one is the cleaning of some mold in mold industry, for instance. There you can see that the mold is cleaned by laser. You can prepare the surface before gluing or before welding. For instance, in this application, it is for automotive industry. And there are two other applications. It is a metal layer removal for on the fragrance bottle for fragrance industry, and there still for automotive industry to remove a plastic layer on some button used inside the car. Another application, another technique for surface structuration is to melt the surface in order to polish the surface. When you produce the melting of the surface, due to surface tension, you will reduce significantly the roughness of the surface. For instance, this is sandblasted aluminum. You can see that reduced by a factor of 10 the roughness of the surface. And this is martensitic stainless steel. The same result, we reduce by a factor of 10 the roughness thanks to the laser treatment. Such application, such process, it's much faster compared to mechanical polishing. There you have the speed. And I will like to emphasize that there is no post-treatment and no cleaning after the laser treatment. Now, if you produce power modulation on the polishing process, you can as well introduce a structuration of the surface. For instance, you can change the morphology. This is a bump that is produced by the power modulation. When you mount the surface, the height is 1 millimeter, and with such application, with such process, we can produce a structuration of the surface. This is, for instance, for a gecko-like structure. This is a wave structure, and this is a structure with positive and negative angle. I would like to underline that there is no, it's a single-step process. There is no post-treatment and no cleaning. The structuration speed is much faster than the laser ablation itself, 10 to 40 compared to laser ablation, and 5 to 10 compared to mechanical engraving. Another technique to structure the surface is to use the self-organization induced by the laser treatment on the target. First, you start in specific condition, you start with ripples, and if you increase the dose, you will switch to some bump, and each morphology has its own properties. For instance, ripples can produce some aesthetic properties and change optical diffraction produced by the surface, but you can also change the reflectivity or the absorption of the surface. This is black surface, is a titanium surface produced by, modified by the laser treatment. It's not burn, it's only some kind of this structure that produce laser trap. It act light trap, sorry, and this significantly reduce the reflectivity of the surface. Now you can use some interference between 2, 3, or 4 laser beams in order to produce laser modulation of the surface. This is, for instance, the interference pattern. And now if you scan this interference pattern on the surface, you will produce a very nice and regular structuration, 1D or 2D, depending on the process. This is some example that we can obtain, and the pitch is about 10 micron. It is possible to go down. Okay, to conclude my talk, I will say that laser technology is quite interesting for structuration in order to introduce some functionalization on the surface, because most of the case it's a single-step process. So there is no risk of peel-off, there is no cover layer. It's a laser treatment only, so there is no chemical, low material loss, it's editing-free and mask-free. In case of reshaping and polishing induced by surface melting, there is no finishing step, and it's ablation-free. It's very faster compared to laser ablation itself. Today, I've presented some example on metals, but it's possible to produce the same kind of structuration on dielectric material, on semiconductors, and so on. As an outlook, the point today is to produce such structuration at a large scale for micro manufacturing, and in order to introduce advanced surface, advanced material. For that, we need beam engineering to support the rise in average power, since we need to produce such structuration with a high throughput and on the large surface. This is, for example, some parts, very large parts, that have been textured with the laser in order to produce some ripples or some black, deep black on the large sample. Okay, this is arrangement, and thank you very much for your kind attention.